A very good morning to you all. Today we'll be considering the concept of distance. Now, in our last class, we looked at the concept of position, where we said that the position in space is always described as an ordered pair of values. So if you're having a body here represented by the set of Cartesian coordinates x, y, that means we are having, this is our x-axis and this is our y-axis. So what we are having, this is our x and this is our y. So now that we can use this to represent any position in space. So if we are having this point, if we have a to be 2, 3, that means this is our x, this is our x, and this is our y. That means this is 2, and this is what? This is our 3. So we talk about this, how we can describe position in space, and how we can also name it in our last class. Today we'll be looking at the concept of distance. Now, distance, as we all know, we can have a body moving at a particular point. From one point to the other, we say that the body has actually covered a distance, right? So what do we mean? For example, if a body moves from point A to point B, it has covered a distance. It has moved from its initial position to its final position and has covered a distance. Therefore, distance is the extent of space covered. Now, it can be an extent of space covered by a particle, an extent of space covered by a body. So today we are going to look at, if we are representing this distance in the set of Cartesian coordinates, and we want to find the extent of space that the body has actually covered, moving from one point in the Cartesian plane to the other. So we are considering this, and let's say we are having 1, this is 2, this is 3, and this is 4. We are having 2, 4, 6, 8. So we are having this position here. You can say that this is A. A is represented by what? X, Y. So we have the first one, which is 2. So we have 2, 4. So this is X. This is our A, right? Good. What if we have another position? We have, let's say, B represented by this 2. So B is represented by 3, by 4. In this case, our X is 4. So we are going to have B is represented by 4, what? 8. You're correct. So we have here to be what? 2, 4, and this 4, 8. So if we want to look at the extent of space this body has covered from moving from this point to this point, so we want to derive an equation here for this distance. So to do that, let's quickly draw our triangle out and see how we can derive the equation for that. So using Pythagoras theorem, this is kind of a right angle triangle, right? So this is our what? This is our x2, this is our x1. This particle has moved to y2 and this y1. Now this is what y. If we want to look at this space, that will be what? Y2 minus y1, and this will be what? This will be what? X2 minus x1. So that means here is going to be what? You're correct. Y2 minus y1, and here is going to be what? X2 minus x1. So we are looking for our distance d. So to find our d using Pythagoras theorem, since this is the bigger side, the hypotenuse, that will be what? The square of the hypotenuse is equal to what? We have x2 minus x1 square, and then plus we are adding, because we are looking at the bigger side, y2 minus y1 all square. That means we find our distance, we now take the square root of both sides. Yes, we now take the square root of both sides, so this cancels this. I have the square root of x2 minus x1 all square plus y2 minus y1 all square. That's very correct. So this is the formula for finding our distance. Now becomes the square root of x2 minus x1 all square plus y2 minus y1 all square. Very important. So we have gotten the formula for calculating the distance between 2 points in space. Now let's look at a typical question here. So we have a question here. Number 1 says that we should calculate the distance between the 2 points P 4,2 and Q 1,6. Now this question is very simple to solve. Just what you have to do is to write your formula out, and then you know which one is your x and which is your y. So the particle is moving from point P to point Q, so we can just choose anyone to be our x1. So we have P here to be what? 4,2, and we have Q to be what? 1,6. So this is our x1, and this is what? Our y1. And this is our x2, and this is our y2. So we can write that out. x1 equal to 4, x2 equal to 1, y1 equal to 2 and y2 equal to 6. So if we do that, we can now, don't forget our formula d is equal to what? D square is equal to, this will give us what? Our x2 minus x1 all square plus our y2 minus y1 all square. So we are going to have our x2 to be what? 1 minus y, that's 4 everything all square, plus y2 to be what? 6 minus y1 to be what? 6 minus 2 all square. So this is our d square. So our d square is equal to what? That's minus 3 all square plus 4 square. So minus 3, that will give us what? Now note, if you square a negative number, it gives you a positive. So it's like saying minus 3 times minus 3, minus times minus, plus 3 times 3, that will give us what? 9. So we have plus 9. So we have 9 plus 4 square is 16. So we have the d square, that's d square equal to what? 25. Therefore d, find the square root of both sides, that will give us what? Square root of 25, that's equal to what? 5 units. That's very good. So we have found the distance. So have you seen that? What you just have to do is to know your x1 and your x2 and then substitute it into the formula. So now we that's it. That's very simple. That's very simple to do. That's wonderful. So just have to note your formula. The formula is very, very important. Let's look at another question. So we're going to look at this this other question. That should be the final question for today. If the distance between point A, that's p comma minus 2, and B 3 comma minus 8 is equal to 10 units, what is the value of p? So to look at this, we are going to look at what we have been given. If you look at this value, we have been given our d. So we have our d square is equal to what? X2 minus x1, and then all square plus y2 minus y1 all square. Now we have given our x1 is equal to p, and then we have a to be what? P comma minus 2, and we have b to be what? 3 comma minus 8. So our x1 is p, our x2 is 3, our y1 is minus 2, and our y2 is minus 8. So if we substitute that, we have that d square is equal to what? 3 minus p, everything square, plus what? We have plus minus 8, minus into minus 2, everything square. So we have the d square equal to what? 3 minus p all square, plus what we have here, we have minus 8. This will be what? Plus 2 all square. So we have the d square equal to what? 3 minus p all square, plus, if you do that, that will give us minus 8 plus 2, that will give us minus 6. If you square that, it's going to give you plus 36. So if you do that, we're going to have that d square equal to what? 3 minus 8 minus p all square plus 36. And our d from the question, our equation is 10 units. So we have that what? 10 square equal to what? 3 minus p all square plus 36. Now 10 square is 100. That will give us, if you open this, you're going to have that if you open this up, you're going to have that 9 minus 6p plus p square, and then we're going to have plus 36, right? And then 9 minus 6 square, I have plus 36. So if we're going to do that, open this up at what? Normal opening of brackets. We have the 3 minus p, and we have 3 minus p. We have 3, that will be what? 9 minus 3p minus 3p plus p square plus 36. Now if you take this one to this side, that will be 100 minus 36 equal to what? 9 minus 6p plus p square. Now if you do that, you're going to have that 64 equal to what? 64 equal to 9 minus 6p plus p square. Now further doing that, you take your 9 down, you have 55 equal to minus 6p plus p square. You're arranging it to form quadratic equation and solving it, you're going to have that if you have that p square minus 6p minus 55 is equal to 0. That's the quadratic equation. If you solve it, you're going to have that p minus 11, and then you're going to have p plus 5 equal to 0. From this, if you solve a quadratic equation, you're going to have that p minus 11 equal to 0. That's p is equal to 11, or p plus 5 equal to 0, which implies that p equal to minus 5. So we take our p to be equal to minus 11. Okay, thank you very much for listening. Hope to see you very soon. Bye.